Finding inverse functions, video 81. Here's a cheap definition for an inverse function. It's a function whose domain and ranges are reversed from its original function. So, here's the function capital F. If we wanted to find the inverse of capital F, we would just simply reverse the domain and range. Domain is x, range is y. Reverse x and y, so instead of 3, 7, 7, 3, and so on. Instead of 4, 8, it's 8, 4. Quite simply, reverse x and y. That is the inverse function of capital F. Let's move on. Find the inverse of g of x. Well, g of x equals x squared plus 3. We ask ourselves the following question each time we look at an inverse function. Is g of x 1 to 1? Well, no. Alright? Therefore, g of x does not have an inverse. Why not? Because since g of 4 equals 19 and g of negative 4 equals 19, we have that 419 and negative 419 are solutions to g of x. Well, that's not a problem. G of x is a function. But if you were to reverse those 2 points, you'd have 19 comma 4 and 19 comma negative 4. Therefore, g inverse would not be a function because each input is only supposed to give you one output. This is giving you 2 outputs. Therefore, so this is basically the reason why a function has to be 1 to 1 in order for us to be able to do the inverse. Alright. Find the inverse of h of x. If h of x equals 5x minus 3, well then, first of all, is this 1 to 1? Yes, this is linear. So we're going to rewrite this as y equals 5x minus 3. Inverse means reverse x and y. So now we're going to have x equals 5y minus 3. Solve for y. Stick an h to the negative 1 over here on the edge instead of a y, and therefore you now have h inverse. Find the inverse of f of x. Is f of x 1 to 1? Yes, cubics. Odd-numbered degrees are typically 1 to 1. So we change the f of x to y, and we just go from there. Reverse x and y around, raise to the 3rd power on both sides, bam, subtract 4, so therefore f inverse of x equals x cubed minus 4. Find the inverse of g of x. G of x equals the square root of x plus 3. Well, before we even do anything, let's talk about domain and range. The domain of g of x is x has to be greater than or equal to negative 3. Therefore, the domain is negative 3 to infinity. Now, here's the deal. Remember, domain and ranges are reversed. So, the domain of g is going to equal the range of g inverse. Likewise, the range of g is going to equal the domain of g inverse. Aha, this is going to come in handy. It says we now find the inverse. Okay, so we're going to reverse y and x right over here. Solve for y by squaring both sides, get rid of that square root, then subtract 3. We got g inverse equals x squared minus 3. So someone might say, well, wait a minute, x squared minus 3 is not 1 to 1. How come we're allowed to have an inverse? Well, we are allowed because, as it turns out, g inverse of x, x squared minus 3, is 1 to 1 from 0 to infinity. Well, someone might say, well, why do we care about that? Well, remember, the range of g of x will equal the domain of g inverse. So the domain of g inverse equals 0 to infinity. If you look at the graph x squared minus 3, it's going to look a little bit like this. That's 1 to 1. Therefore, you can have an inverse as long as you have a restricted domain. Alright? So good times on inverse, and we'll talk to you later.